again everyone, I am Hanita, and in today's video we are going to dive into deep learning project for sentiment analysis using LSTM. So without further ado, let's move on. Okay, the purpose of this project is to build a sentiment analysis model using LSTM, meaning long short-term memory, okay, to automatically analyze and classify the sentiment expressed in text data. Okay, let's take a look at these texts. Okay, I am not happy but not sad, hopeful yet humble. I know it takes a village to make change, so I am slowly building one. What do you think? Is this a positive statement or a neutral statement or negative statement? You got it? So basically, sentiment analysis is a critical task in natural language processing, okay, NLP, that helps us understand the emotions, opinions, and attitudes of user, which can be invaluable for businesses, researchers, and decision makers. Okay, so in this project, right, let me just go further in making you to understand, okay, because LSTM is a very powerful tool for sentiment analysis because it can understand the context and relationships between words in a sentence, making it perfect for your deep learning project. For example, if I say this sentence, okay, I did not enjoy the movie, so the LSTM will recognize that the word not, okay, negates the sentiment of enjoy, so correctly classifying the sentence as negative. Alright, so anyway, without further ado, let's begin our hands-on experience using this LSTM in our project. Okay, so let's open up Google Colab. So I already renamed my file to sentiment analysis, and the next step I want you also to do is to click on this runtime and go to change runtime type, okay, and change it to T4 GPU. By default is CPU, but I want you to click on choose T4 GPU. Why? Because for deep learning tasks, switching to TPU, okay, is much faster computation, okay, also leads to better efficiency and lower training time, right? So do that and click save. Okay, and the next step, you know that every of your work is we're going to get the data set from Kaggle because I do not have any data set yet for this sentiment analysis. So what I'm going to do, just click install Kaggle. I'm sure you have learned this from the previous video that we have done also on dogs and cats classification, right? So just click install Kaggle and run this. Okay, in the meantime, while it's running, just open up another tab. What I want you to do, I just want you to type, let's say, movie review. Okay, let's type movie reviews. I'm going to get these movie reviews from Kaggle. Yeah, great. This is the first one that comes out. So I'm just going to use this data set. Alright, so basically looking at this IMDb data set of 50k movie reviews, you can see that the review has 49,582 and the sentiment has two values, which is positive and negative. Alright, so great. So I will be using this data set. Okay, let's get back here and see. Okay, great. Yes, everything is already installed. So the next step is maybe I do a text first, and I'm going to write importing dependencies. Okay, so start importing. Like for example, I want to import oops, what's this? Okay, I want to import OS. Okay, what is OS? You know that OS is operating system. And why is it used here? Because basically in Python, right, the OS module in Python provides functions for interacting with the operating system. So OS actually comes under Python standard utility modules. Okay, so just you has to import the OS, that's it. And also, if you remember the last video, I also import JSON. And this JSON file is something that I already taught you how to download, right? Basically, you have to, okay, let me just open up another kaggle.com, alright, because I don't want to close that one. Okay, so how you get the JSON file? Basically, you just have to sign up Kaggle, and then once you sign up, you have to verify yourself, and then once you verify yourself, you can just click on your profile and go to settings. Once you go to settings, you can just go all the way down to the API. You can click create new token. Okay, for me, I don't want to create new token anymore because I already download the file. So when you click continue, it will automatically download for you. Okay, that is the JSON file that we will be using. Okay, so let's get back here. Okay, so I already import JSON, and you know that this file is a large file, so basically they have compressed all these files. So what I'm going to do, I need to unzip the file. I need to decompress the file. So how I'm going to do, I'm going to just from zip file. Okay, this is also we have done in the previous video, right, about the dog and cat classification, right? So from zip file, import zip file, yeah, just like that. Okay, and definitely we also need import pandas as PD. Okay, this is a basic thing that we have to know. Okay, and then definitely we have to use sklearn for the train test split, right? So from sklearn dot model dot selection import train, yeah, train test split. Okay, definitely we have to train the data first and test also to split it. So we always need to do to use this sklearn, okay, for selection train test split. Now what else do we need? This is a deep learning, so remember for deep learning we need to use TensorFlow. So from TensorFlow, TensorFlow, sorry, dot Keras. Okay, I'm going to use Keras. Okay, I'm no longer need image data generator, right? Google Colab. Remember that I've used this for the dog and cat classification for the last video. So I don't need this. It's not an image. This is more text. Okay, so I'm going to remove this. And what we're going to do is we are going to, not, okay, Keras layers. Okay, we are going to do Keras models, not Keras processing. Wait, just hold on a second. Keras models import sequential. Okay, why is it sequential? Quentil. Okay, basically what this means, basically this is a linear stack of layers where each layer has one input tensor and one output tensor. Okay, so it's ideal because we are using these simple neural networks that process data in order, in order, because we're using LSTM, right? So that's the reason why we import this TensorFlow sequential. All right, and then we also need to use what else? Okay, we need to use, definitely we need to use the LSTM, right? So again from TensorFlow. Yep, it types for me. Great. Keras layers import dense, but not drop out. I don't want the drop out. I want embedding. Okay, which I explain to you later. And LSTM. Okay, so as I've mentioned, okay, what is LSTM? I already mentioned it earlier in the very beginning of this video. But dense, what is dense? So dense is basically a fully connected layer, okay, used in the feed-forward and recurrent networks. Okay, so that's the reason why I am importing also this, using this dense also. And embedding, basically embedding, it will convert integer encoded words, okay, into dense vector, okay, or fixed size. Okay, so that's the reason why I also use this. I want to also import this dense embedding as well as the LSTM. Okay, as you know, this LSTM I already explained to you, right? So, what else do I need? Okay, I haven't, okay, this one model checkpoint, now I don't need this, I'm going to delete. So from TensorFlow also, I need something called tokenizer. Okay, I haven't explained to you tokenizer. Basically, what tokenizer do, right? Okay, let me just tap this. Okay, this tokenizer basically it converts text, okay, into sequence of numbers like word indexing, basically. Okay, and also pet sequence. I need to import pet sequences also because this one is to ensure that all sequences have the same length. So by adding zeros or truncating the extra words, so everything will be in the same length. So that's the reason I need this pet sequences and also tokenizer. All right. Okay. Now next, what I'm going to do, I'm going to continue the code or maybe give a text. Okay, maybe I run first this. There's something wrong with this sklearn, yeah. Model dot selection. I forget the T. Selection, yeah. Okay, sorry about that. Oops, also wrong. SELECTION. What is the problem, yeah? From sklearn model underscore, yeah. Why did I put a dot over there? Underscore selection. Okay, import twin test. Keras also dot model. Okay, Keras is dot model. Mm, models, layers, this is correct. Okay, so let's try to run again. Yeah, it's a thickness is correct. Even it underlines certain things, just ignore it. Okay, doesn't matter. Okay, now we're going to go for the text. I'm going to make a title of data collection. Okay, because I'm going to collect the data from the Kaggle, right? So we're going to use the Kaggle API. Remember, it's from the JSON file. Okay, maybe API. I put this uppercase. Okay, so what I'm going to do is that I use Kaggle dictionary. Kaggle dictionary is equals to json.load. Okay, content Kaggle.json. Okay, this time I will not put in the content. I'm lazy to search for the content. So I'm going to do, I'm just going to upload. Remember the one that I have told you here? Wait, just let me show you again. Okay, I just go to create token. For you it's create token if you have never ever had a token before. Okay, for me create new token, but I don't want to create new, I already have the token. So you just click create new token and it will download for you. Okay, so yep, I just going to upload it over here. Once from there you re-download it, will upload here. Okay, go open. Alright, just click OK. Okay, this one is straight not under content, so I will just remove all this Kaggle JSON. Okay, and okay, so basically what this Kaggle dictionary is about, this is just, okay, let me just write a comment so that you will understand better. Okay, so basically this Kaggle dictionary is just a variable that I make. You can use any name that you want also. Okay, this is just a variable, but here it will opens the JSON file that you upload here. Okay, so that is what it do. Okay, it will load, sorry, it will load the JSON file. Okay, this one, load the JSON file. If let's say I were to just let me show it to you. I would print Kaggle dictionary, right? It will actually print my username and my key. Okay, let me just print for you. See, the username is Hanita Abdul Hamid. Key, this is based on my Kaggle JSON that I took from my API, right? Because this is this set of Kaggle API credentials as environment variables. This is like to prevent exposing sensitive information in your code. So like I don't want to show this to others people. So if I were to type this, okay, people can just copy my code, my key also, and then they can reuse this. So I don't want. Okay, so that's the reason why we, instead of just putting the key, my key and my user ID straight away. My username I don't mind, but for the key, everybody's key is different. So instead of putting the key, just not the number over here, right? I just create a dictionary to load the file, and then it will actually show me, only me knows the my user ID as well as my key. Nobody knows. Okay, that's the reason why I substitute that with Kaggle username and Kaggle key. Alright, so that's the reason that you have also have to get this Kaggle JSON from your own account, okay, from your own profile itself over here. Okay, you have to create your own token. Okay, then what I will do next is I will also okay, if you were to print the Kaggle credential successfully, right, definitely you will say it's correct lah. Alright, so anyway, let's move on. So I'm going to get the Kaggle data set from this here, right, this site here. So what I'm going to do, maybe okay, over here, okay, don't worry about this. Okay, I will provide for you the link this in the description below, so right, so you can follow along. Okay, I can copy over here the Kaggle data set, so download. But you don't have it here, yeah. That's funny. So where should I go? Maybe I can just go to the code here. Yeah. So I can get this one. Basically this is the URL. The Kaggle URL. So I just copy this part here. Control C. Okay, so maybe I can just write in what should I write now? Kaggle. Okay. Remember to put the exclamation mark, yeah? So here already write for me Kaggle. Okay, I just tap Kaggle dataset, but I'm not using this. This is for the real new fake news dataset which I have done before, but I'm not going to do this. This time is about the movie review, right? So I leave it to D. I just remove this. I just Control V. Okay, so I'll remove this part. Okay, don't worry about this as I will also provide for you below the description. Okay, I know maybe the person that provide this data set, his or her name is Lakshmi. Okay, so we just copy from the data set. This is the data set that is given, the latest version of the data set. Okay, so that's it, and you can just run this. Okay, this will take some time, so oh, that's quite fast. Okay, great. It's 100% already. Good. So I can actually list also to see the data set, okay, whether it's a zip file, etc, etc. What's the name actually? So I can just put list so I can see. Okay, so the data set is IMDb dataset 50k. Oh, it has 50k movie reviews. Zip, yeah, it's a zip file. Okay, great. So since I know that it's a zip file, right, later on I have of course need to unzip the file. Okay. Okay, so now maybe I make a comment this, lazy to make the text, so unzip the dataset file. Okay, so I'm going to do, so we've, remember we have import the from the zip file to import this, right? So we just use with zip file and just copy this. Yep. Okay, if it doesn't automatically write for you, you can just copy this. That's the reason why I do the list. Okay, so you can just copy this, so it's exactly the same, right? Then R as zip reference. Then zip extract all. Okay, so extract all, it should close it. Yeah. Okay, so when you run this, it should give you, oops, why is it a mistake? Yeah? Let me see. IMDb dataset of 50k movie review dot zip, yeah, comma R as zip underscore ref, zip reference extract, extract, right? Extract all. Zip file is not defined. Oops. Okay, it tells me I typed wrongly here. Small letter, sorry about that, yeah. Okay, now it should be okay. Okay, so once I have unzipped the file, I want to load the dataset. So what I'm going to do, okay, this time maybe I just like do the text. Okay, so load the dataset. Alright, so remember how to load the dataset. Maybe I will just define this dataset as data. Okay, so data, or you want to put SDF also can, up to you. So just put pd.read underscore cv. Yep, this is it. IMDb dataset. Okay, remember this is the IMDb dataset over here. Okay, IMDb dataset, and it's already download from me here. So I want to download here since it's ready. I ask it to from here, right? I ask it to unzip. Okay, so already unzip for me. So this is IMDb dataset. Okay, so now I can run this, and then I want to see the shape, like how many columns and rows are there in this data set. So I just go to data.shape. Let's try to see. Oh, there's 5,000 data set, means 5,000 columns and 2 rows. Yeah. Alright, so yeah, it's like that. I think there's 5,000 all people commenting, reviewing, and 2 rows, 1 and 2. Okay, 2 rows. Okay, great. So at least I know how big is the data. Alright, now what I'm going to do, maybe I just let me show the data hit, a little bit of data hit, just the first 5 columns. Okay, so okay, so all these 5, 1, 2, 3, 4, only one is negative. Is okay, so you can see that only one is negative. Alright, let's try to see the tail. Let's see data dot tail. Okay, and see. So below part has more negative than the first 5 rows. The first 5 rows all positive. Okay, good. Now let's count, okay, how many positive are there and how many negative are there, because like you just see the head and tail, you didn't really see how much people actually, how much of the sentence actually after being calculated to be positive or negative. Okay, so let's try to make the count. So data, as you can see that this part is a sentiment, the positive and negative has what do you call it, the title inside the row, which is called sentiment. So I'm going to put data sentiment. Okay, and just put value, call value counts, value underscore counts. So this will count for me. Okay, great. So now we know the positive is 2,500, negative is 2,500. So which is good. Okay, all the integer is the data type is integer 64, which is numeric. Okay, so this is balanced. Both are similar numbers, so both negative and positive are balanced, which is good also. Okay, so since we know that this data type, right, is the count is integer, but the sentiment is a text, right? So in order to change this, okay, sentiment to a value of not really value, because this, sorry, this count is positive and negative, right? So I want positive to be 1 and negative to be 0. Okay, so I can understand the data. I mean, the model will be able to understand, because computers, as you know, they don't understand text, they don't understand objects, image, all they don't understand. They only understand numeric, right? So I'm going to convert this positive and negative to numeric, which is called hot encoding from 1 0. Okay, so what I'm going to do, I'm just going to like data dot replace the one that I want to replace is the sentiment column, right? And this one, I want to replace it as positive. For positive value, it will be 1, okay? It's not standardized. I want it to be like this. Okay, there's one standardized. Okay, so positive will be 1. And, why did I type outside? Sorry. It should be inside this bracket. So it will be 1. And negative should be 0. Okay, yeah, it types for me. Great. Okay, so in place true, so this should be true. Okay, and I will just run it. If you run it right, you cannot really actually see anything, but it has done it. Okay, wait, I got mistake here. The sentiment, I should put a bracket over here. Okay, curly bracket. Yep, and close over here. Shouldn't be. Yep, it should have a close bracket here. Okay, and also, yeah, over here shouldn't be here. It should be positive and close here. And from the sentiment also, before the sentiment also, so by right it should have 2 closing over here. 2 of the curly brackets here. Okay, it's always type. Okay, alright, so let me run it again. Okay, so this one is to just show you that the sentiment positive is equal to 1 negative is already done. Okay, so if you want to check it, of course you have to type lah. Okay, that means print again data dot hit. So when I do that, right, it will not show me positive negative, but it will show me 1 and 0. See, the positive is 1 and negative is 0. Okay, instead of positive negative like this. Okay, great. So yep, so the count, just to remain to ensure, right, is really the same. So I can just copy this again. Okay, actually it should be the same, but just to be double confirm. Okay, so yep, the count of 1 is to 50, positive is to 25,000, and the negative 0, which is 0, is 25,000. Okay, so now let's try to split data into training data and test data, which we have already import, right, from the very beginning, the sklearn, the train test split. So because we already import, we don't need much coding, we can just reuse it. Okay, so just one line. Okay, so let me just comment split, or maybe I just use text lah, nicer. So split data into training and test data. Okay, so what I'm going to do is I'm going to create a variable called train data and also test data. Okay, and just make use of what is an sklearn, that is train test data split data test size 0.2. This 0.2 basically I want to the test size is 20%, which makes the train to be which make the training data to be 80%. Okay, maybe also I want it to be random state of 42, so that it will be always when it runs, it's always running at random state of 42. Okay, so let's try to run this. If you run this, you'll not see anything until you try to print. Okay, let's try to print it. Print train underscore data. Yeah, great. I just tap. Okay, so you train the data shape and test data shape. So what will happen basically, this will just print the dimensions of the training data set. Okay, so out of 25,000. Okay, sorry, out of the 50,000. Okay, the 50,000. Where is it? That total is 50,000, right? 50,000, right? And there's two rows. So basically, it will train for 40,000 out of 50,000, and it will test 10,000 out of the 50,000. So it's like 20%, 20% of test and 80% of training. Okay, so okay, now let's do the data pre-processing. So let me just comment it first, maybe data pre-processing. Okay, and I will code it. So remember, we have already used we already import the library of the tokenizer here. Okay, this one. So we are going to use this for the pre-processing. Okay, so what we're going to do, tokenizer text data. So tokenize text data. Okay, so tokenized text data, basically it what it does, it just turns the raw text, all this text, right, that people have reviewed, into a form of sequences of integers. Okay, which is very suitable for deep learning models. Okay, so for example, right, let me just show it to you an example. This is totally out of the the what you call it, this project, but just to show you something. Okay, let's say I do a text, then I just type this text. Let's say the text is, let's say I put I am Hanita, for example. Okay, and then but I love programming, for example. Oops. Okay, and then what else? Maybe another one. Oops, let me go inside here. Okay, maybe another string, another sentence. What should I say? Okay, maybe machine learning is awesome. Let's say, okay, awesome. Alright, so yeah, I don't need this. Okay, so what happens, right, when I print this text? Okay, before I print the text, I create tokenize. Okay, tokenize text data already done for me. So great. If I tokenize this text, all this tokenizer is equal to tokenizer is equal to tokenizer. Okay, tokenizer feed the text over here that I type in. Sequence is equal to tokenizers text to sequence text, and it's going to be in sequence, the numbers. Okay, so when I print sequence, what happened? Oh, there's something wrong with this. Wait, I forgot to close this. Okay, now should be fine. This one is a forget close. Sorry about that. Okay, so yeah. Still, I'm Hanita. I love programming. Machine learning is awesome. Why is it? I am comma. I love programming comma. That should be what the text. Oh, sorry. Shouldn't be having indentation. Yeah, all this I do not know why I have indentation. Sorry about that. Just wasting time. Sorry about that. Okay. So when I run this, right? Again, text equals to, this is the text I want it to be, right? So yeah. Okay. Basically, it just convert all these to numbers and in sequence. Okay. Alright, sequence text. So this is what it means. I hope you understand that. Alright, so let's move on. Now I'm going to take the real text. It's not my text, this one, okay, but the real text, which is the review text inside this data set. So what I'm going to do is that, again, I'm going to call it as tokenizer. Okay, so tokenizer. Yep. they give me number words is 10,000. I don't want 10,000. Just now I just type three sentence, but here I just give it 5,000 because 10,000 is so much. Okay, and then tokenizer. Okay, I'm going to make it fit. Yep, I'm going to fit this tokenizer text. Okay, which is this text is not my text but is the review text. Okay, so it is inside the train data, which is the review text here. And yep, and remember, right, you have also import the pet sequences. Where is it? Yep, this one, pet sequences. Okay, so basically I've mentioned to you what this pet sequences is about, right? So basically what does this pet sequences did is that it will ensure that all the reviews have the same length. Okay, I don't want it to be some maybe 500, some only 100, some maybe 50 only, or maybe 20. So it will cause imbalance. Okay, and that will leads to errors and not good uh, assurance of the model later when they do the training, right? It will not be accurate. Okay, so that's the reason why I want to use the pet sequences to make it the maximum length, for example, to be, let's say, 200, to make it more both balanced. Okay, right? So those texts maybe they just says, oh, I like it, just 3 sentences, and the rest give so much and long comments, review. Then you would the one with a long review will be dominating, right? So I don't want that to happen. Okay, so that's the reason I use the pet sequence. Okay, so I'm going to use this feed uh review row as x. Okay, so I'm going to set x train is equals to pet sequence. Yeah, remember I've explained to you what pet sequence is all about. So pet sequence, and create the type for me. Okay, this they give you maximum length of 100, but I think I will just put it to 200 now. Okay, so in other words, if the comment, right, is more than 200, it will be truncated, but if it's less than 200, it will turn all these to 0, 0, 0, 0. Okay, so let's try to run this, but if you run you can't see anything because you need to print. Okay, so let me put the code again here. So print while it's still running. I don't want to waste time. I can just print first. Okay, so I'm going to just print the x string. Okay, I'm going to print the x string first and see. Yep, it has changes all the text over here. Okay, to all the 500 text, because I said 5,000. Okay, all the 5,000 text here randomly. Okay, whichever, it's not like on sequence like 1 2 3 4 5. No, it's randomly. Okay, and with the maximum length of 200. So and convert it to numerical values. Okay, so let me try to print the x test now. Print x test. Okay, so if I train this, yeah, the same similar is also been converted. So you can see that the value is not super much difference, where it has 0 1 6 1 also, so it is quite balanced, right? Okay, I did for the uh, row review. I also have to do for the sentiment value, so maybe I call the sentiment row as y. Okay, so I do it as y train equals to maybe train, oops, train, yeah, yeah, they did type for me actually, train data, yeah, sentiment. Okay, so also you do it for train, you also have to do the testing. Okay, so the same, similar, just now you do it for the x train, but x test train, x train and x test, but design for the x train you need to do the pet sequence, the tokenizer, but for the y train you don't need to do tokenizer anymore, because this is sentiment which only has 1 and 0, because they already convert, right? Remember, before that it was positive and negative also is not sentence, it's just one word, so it's easier for you to just convert it like one hot encoding from 1 to 0. So we don't need tokenizer for this, okay, why train. So then we just run it, and let's try to print. Okay, so when we print the y train, print y train. Okay, I always start capital letter for print now. Print y train. What happens? It will print for me. Okay, that is, remember 0 is negative, right? Yeah, 0 is negative here. Okay, I put the values of 1 and 0, is it? Yeah, 0 is negative, 1 is positive. Yeah, positive and negative, and I want it to convert just now. I change it right here. Positive is 1, negative is 0. Right, so 1 is positive. So basically positive is only a little bit here, negative is all there. Okay, so for positive people that comment is about 45,270 is positive, 39,000 okay is negative, for example. Okay, then maybe I can also now start to do, okay, this is the excitement. Okay, let's do the LSTM model. Okay, so LSTM, remember what it means? It means long short term memory, right? Okay, so this is the algorithm that we're going to use. So maybe we build the model now. So we use, I just name it as model is equals to sequential. Yeah, we already import this, right? Remember earlier, this from TensorFlow. We're going to use this. I'm going to use this dense and embedding, and also I use sequential, and I'm going to use this dense embedding and okay, LSTM. So yep. Okay, so when I train the model, I will just use sequential firstly, and then uh, so this will initialize the sequential model, yeah. And then next, I will use the embedding layer, basically to convert the words taken into dense vector representation. Okay, so what I'm going to do is that I'm going to use model, oops, model dot add. Okay, let me just type first, then I will explain to you lah. Okay, oh good, it's already typed for me also. Okay, good is like, because they know that I already mentioned I want to take like 5,000 number of words, right? So use here 5,000. Okay, okay, 1 to 8 input length is 200. Okay, also here input length is the 200. Yeah, maximum length is 200. Okay, great. For this one, LSTM 1 to 8, I leave it, but dropout is 0.2. Okay, basically what is this dropout 0.2? Okay, if you want to know, this dropout is actually to prevent overfitting. Okay, so I give it 0.2, which is 20%. This will prevent overfitting by randomly dropping like 20% of connections. So that's the reason. Okay, for 1 to 8 is actually the number of LTSM units, the memory cells. If you do not know, right, you just highlight, then actually that thing will also come out and explain to you, right? So this is a good thing about Google Colab also. And then okay, what else so I want to write? Yeah, okay, I also need to mention that this, the dense, remember that we have imported some model, also you add the dense. Yep. And I don't want the okay, activation sigma. Okay, great, great, great. Yeah, it types for me. So what this dense basically did, right, this dense output, right, is the layer, the final layer for the binary classification, which will output one, the neuron one, right, will output a single value probability. Okay, and activation, I want it to be sigmoid because when you use a sigma activation, right, it gives you probability of 0 to 1, which we have our this one is positive or negative is 0 and 1, right? So that's the reason I use this. Okay, so let's run this, and then what will happen? It will not run because I didn't not type in the summary yet, so I will put model dot summary, so it will summarize for me. Okay, yeah, so the output shape is still unknown, it's just question mark. So this is embedding LSTM dense. Okay, so good. All right, so now when you already has done the modeling using the algorithm, okay, to train the model, I'm also going to compile the model, remember, using the Adam. Okay, so let me just do the optimizer Adam. Okay, optimizer Adam is very good because it helps adjust the weight efficiently for better learning, so that the machine learning is able to learn better. Okay, it also it acts like optimizer lah. It really create efficiency and widely used for deep learning. So just make use of this Adam, which is very very simple and fast also. Okay, so what I will do is that here I just comment it, compile the model. Okay, and yep, oops, compile the model. CUMPILE. Okay, great. I spell it correctly. Okay, then you use model compile. Okay, I'm going to use the optimizer called Adam, right? So optimizer, OPTIMIZER. Definitely optimizer Adam is to optimize it lah. Okay, so yeah, you also type for me because I used this before, right? So okay, Adam, loss binary, cross entropy, matrix accuracy. So just leave it like that. Okay, so I want it to be totally accurate and being optimized. Okay, so once you have done this, right, you can actually try to train the model. You have do the LSTM. You have also done the you have also processed the data with the tokenizer, right? Okay, so you can actually um, try to fit everything, okay, inside. So model.fit. Okay, so I'm going to fit the X train, Y train, okay, everything lah. Okay, Y train. Okay, I don't need okay, they give me batch size 32. Maybe I use batch size 64. Let's try. Okay, 64. What else? Epoch 10. Maybe I just just leave it lah. 10 is okay. Validation data X. Validation data. Okay lah. I think I will just put validation. Okay, I just leave it like that. You can change it validation split to 0.2% also can. Okay, so this is up to you. But this will take few like maybe 1 to 2 minutes. I'm not too sure. But just now also we have already changed the runtime to GPU. So let's see how long does it takes to run. Yeah. It's 625, you see. So it takes some time. So let me just stay tuned. Don't go away. Okay, I will pause the video and come back again. Once you have done this model feed, that means you have trained the data, right? The next thing is, of course, we need after training, we need to what? We need to evaluate, okay, how much accuracy is there. Okay, so let's do model evaluation. So let me just give a text first. So I'm just going to write here model evaluation. I'm going to browse up a little bit more so I can see it. Okay, so now I'm going to give a code. Okay, I already have a code actually. So let's see. Okay, if I put loss and accuracy, let's spell it correctly. ACCU. Okay, great. Okay, now I just tap. Okay, so it's right for me. So model evaluate X test, Y test. Yes, correct. So yeah, this is what I want. Okay, and then once I did this, of course I want it to print. Okay, to show it what is the test loss. Okay, let's say I just give a name test loss. Yeah, it great. Now it typed for me. Okay, so I need to type. Oops, loss. Okay, never mind. Really lost. I clicked wrongly. Okay, never mind. So this one will be the loss. Okay, yep, now up again. Okay, now press enter. So I want it to print for me the test loss and the test accuracy. Okay, and of course this one you have to also close and close the bracket also. Alright, why is this one got error? Okay, because I'm using this curly bracket, right? So I need to put this in front of. Okay, so let's see. Test loss. Okay, this one also I need to like put something like this, like select that. So it will tell me, okay, this is the number of test loss and the number of test accuracy is this. Okay, so let's try to run this. Of course, you know, I shouldn't put it here, the closing. Oops. Why is it automatically here? Okay, close it over here. Okay, yeah, so this one also close here and not here. Right, so now let's try to run it. How come not to? Okay, alright, so let's try to run. Okay, this one also will take, but not super long as the previous one. This one because they are training the model, right? So actually here also they show us louder, but every step of it they tell us what is the accuracy, what is the loss, etc. But here I want just the overall, okay, from everything. So let's see how much is the loss and how much is the accuracy. So how accurate it is and how much you know, like error that is. Okay, so kind of like, let's see. Okay, so while waiting that, I don't want to waste time. So it prints out for me already, but actually haven't. I'm still running. Yeah, okay. So test loss is 0.3, okay, which is not bad, and test accuracy is about 89%. Okay, not bad, yeah, not bad lah. So this one is still acceptable, yeah, it's still good, considered good, yeah. Okay, now we're going to, once you are happy with these results, okay, then you can just start to build the system, the predictive system. Okay, so let's building a predictive system. Okay, okay, I'm going to create a function so that I can call it back again. Okay, so let me maybe redefine. Maybe I'm going to call this function as predict sentiment. Okay, predict underscore sentiment. Oh, great. Okay, so the sentiment is from the review feature, right? Okay, the review feature is where the, remember this one, the viewer or the customer, what do you call it, write down whatever the text, like movie is good or not good, or basically there's okay, whatever review. Okay, so this is it. Okay, and then what is the preprocess? Okay, and after that I'm going to use the tokenize and the pack. Okay, tokenize and pack the review. Okay, so let me just use tokenize and pack the review. Okay, so again you're going to use here sequence. Yeah, you're going to use sequence. I'm going to give a name variable for sequence because I'm going to use a sequence tokenizer text, okay, that we have imported, remember. So let's see, tokenizer, that is like the previous step, right? Actually we have trained this, but when we do the definition I want it to do it again. So alright, whatever you know that it has processed the data, etc. Okay, you will need to be noted of this, take the action again of this training. Okay, so this is review. Then padded sequence, I'm going to call it by sequence. For the pad sequence, yeah, the maximum length is 200. Okay, and of course I'm going to make the prediction. Yeah, predictions for model predict padded sequence, which is this one. Okay, and then now I'm going to give the sentiment, which is sentiment. For the sentiment, remember the sentiment features is the positive and negative that we already convert into 1 and 0 also, right? But here, yeah, we have to always, like, I want it to print positive or negative, so I want to say, I don't want it to print 0 or 1, so I want it to print positive or negative. Okay, so I'm going to make sentiment equals to, yeah, they tell me for me. Wait, so positive, if prediction is more than 0.5, sorry, if prediction is more than 0.5, then you will print positive. Else, okay, if let's say 0.4 or 0.49, okay, lesser than 0.5, then it will print negative. Okay, then it will return sentiment. So, okay, I will give you an example. Okay, for example, maybe example usage. Okay, example usage. I forget the comment. Okay, so we can try this out. Okay, so let's say okay, new review, because I don't want to use that review just now. I just want to make a new review. Okay, so new review is equals to, hey, they even give me wow, this Google Collab really, I haven't published it. Okay, fine, I'm gonna use it. So I'm gonna say this music was fantastic. I love every minute of it. So predicted sentiment is a variable that whatever you can actually make your own variable, but since already typed for me, so I make use of this predict sentiment. So predict sentiment, the new review. Okay, so based on this review, whatever you type here, they will take this and print the result based on the predicted sentiment. Okay, alright, so let's see if you were to, okay, still it will print say predicted sentiment is good process. Can you see that? Because it's really positive, right? But if I were to, okay, let me try to make another one which is negative. Okay, another example usage. Okay, so this one maybe I put new review to review. Okay, maybe this one I change new review, I put it to 1. Okay, also print 1, so I can print it. Okay, positive. So this one new review 2. Okay, so they always type for me. Definitely this acting was terrible and the plot was boring. So okay, this definitely negative, right? So what happens? Okay, now new review 2, when you play, okay, it will say negative. Okay, maybe I put something not so clear. Okay, maybe this movie was alright, but the ending is not very cool. Okay, so let's see what kind of negative. Yeah, okay, let's say the actor and the actresses, yeah, spell it correctly, actresses, is it like that? My spelling very bad, sorry, I spelled wrongly here. The actor and the actress has performed very well. Okay, let's see. So let's try to run. Positive. Okay, so great. So you can see that the accuracy of 89% is good, yeah. So it's able to analyze the statement of your words quite accurately and predict it correctly. Alright, so I hope you have enjoyed this video tutorial and you have do it together with me. And if it's really beneficial for you, please subscribe down below and share it with others too. Thank you.